Welcome boys. This is my 7th video on method of integration. We are discussing method of substitution for solving the problems based on integration. And we have so far discussed 3 types. Now today we will discuss 2 more types. Now in type 4 we may have integrations of the form integral dx divided by a cos x plus b sin x. We may have this type of integrals. Boys, in order to evaluate such type of integrals, we always try to divide numerator and denominator by root over a square plus b square. But one thing must to be kept in mind, that in front of cos we have this angle x, and in front of sine we should have the same angle. Remember, if instead of x, if we have a cos 2x and then b sin x, you can't apply this technique. This technique is applicable only when in front of cos as well as sine we have the same angles. Say if here 2x, then here also we have 2x. If here 3x, then here also we have 3x. Then in that case, you should divide numerator and denominator by root a square plus b square, and your integration becomes more easier. Now how to solve? Let us take an example. Say boys, I is equal to, say I is equal to integral dx by 3 sin x plus 5 cos x. Say we have this result. Now if we observe, here we have a is equal to 3, b is equal to 5. So what about root a square plus b square? Root a square plus b square is equal to root over 9 plus 25. That is root 34. So you are getting the value of root a square plus b square as root 34. No problem. You have to divide this numerator and denominator by root 34. But do not try to show this result here. You have given this integral I is equal to, and you want to solve it. Just you use your calculator in mind and try to find out the value of root a square plus b square. That is root 34. So we can write integral 1 by root 34 into dx by, here you can write 3 by root 34 sin x plus 5 by root 34 cos x. Now after dividing it by root a square plus b square, we will try to adjust this denominator using compound angles. Now how to apply compound angles here? Here you see 3. So this 3 cannot be directly taken as sine or cos of an angle. You can't take this 3 as sine alpha, because this must lie, the range must lie between -1 to 1. You know it, that sine alpha lies between -1 to 1, cos alpha lies between -1 to 1. But if we divide it by root 34, the whole expression becomes smaller than 1. Now we are able to reduce these two expressions in terms of sine and cos. So you can take this expression in terms of sine or this expression in terms of cos. This will depend on you. So let root 3 by root 34 is equal to cos alpha. Say, therefore 5 by root 34 is equal to sine alpha. If you prepare the right angle triangle, there you will find that once if you are taking the value of cos alpha as 3 by root 34, say this one is alpha, this one is 3, this one is root 34, then this value should be 5. So if cos alpha is 3 by root 34, sine alpha becomes 5 by root 34. And what about the value of tan alpha? Tan alpha is equal to 5 by 3, which implies alpha is equal to tan inverse 5 by 3. You see here from this right angle triangle we can say that tan alpha is equal to 5 by 3. So alpha is equal to tan inverse 5 by 3. Now this value of alpha, it helps us to write the answer in numerical terms. We can replace this alpha using tan inverse 5 by 3. Or some people may write alpha is equal to cos inverse 3 by root 34. Or alpha is equal to sin inverse 5 by root 34. But in general, in all the books you will find alpha in terms of tan inverse. So that's why we are writing here alpha in terms of tan inverse. Now what happens, as you can see, therefore I is equal to 1 by root 34. You can take out in numerator integral dx by, now this becomes here cos alpha into sin x plus sin alpha into cos x. So this result you will get after putting the value in terms of alpha. Now, here one more thing is important. You must keep in mind that whenever you are reducing this using compound angle, you have to write x first, then alpha. So this is equal to 1 by root 34 integral dx by sine. First write the value of x plus alpha. You see here, sometimes if it is minus given here and if you are writing alpha minus x, in case of plus there is no problem. Whether you are writing x plus alpha or alpha plus x, it has same meaning. But if it is minus and if you write here alpha minus x, then it becomes wrong. So that's why always try to write x first, then apply the formula, then check it and then write this value. Now this sin x plus alpha, if you write in numerator, it becomes 1 by root 34, that is integral cosec x plus alpha into dx. Now the integral of cosec x, you know, log mod cosec x minus cot x. So we can apply directly the formula here because x is free from any constant. That's why I am writing direct the formula. So what happens? This is equal to 1 by root 34 log mod cosec x plus alpha minus cot x plus alpha mod closed plus c, and we have to write the value of alpha here, or you can write here where alpha is equal to tan inverse 5 by 3. So this simplifies your calculations, workings, that you have taken alpha is equal to tan inverse 5 by 3. It is understood here and your answer is of this form. Some students may simplify this cosec in terms of sine, here cos and sine, and then they will take the LCM and they can write the answer in some other modified form also. That is also correct and this form is also correct. So this is your type 4. That in this type, whenever you are getting dx by a sin x plus b cos x, you have to divide it by root a square plus b square, and in denominator the first term should be taken as sin alpha, constant term, then the second constant term will be cos alpha, or if you are taking first constant term as cos alpha, then second will be sin alpha. And using compound angles you can simplify your result. It reduces to either sin or cos. If it is in terms of sin, take it in numerator, it becomes cosec. If it is in terms of cos, take it in numerator, it becomes sec. And both the formulae you know. In case of integral sec x dx, you know the integral is log mod sec x plus tan x. So boys, in this way you can solve these problems. Now we have to discuss one more type, and this completes your method of substitution for HS, that division by x square. Division by x square. In many of the problems which we solve in future, so we have few problems in which we have to take this technique, that we have to divide it, the whole integrand, with the help of x square, and it reduces to our required form. Now how? You see here, there are a lot of problems based on this technique. We will discuss in due course, but here to solve few problems based on this technique, you see, I is equal to integral, that is x square plus 1 divided by x minus 1 whole square, or x square minus 1 whole square. Suppose this is the problem, dx. Now boys, this technique is basically applicable in those problems where we are getting x power 4 in denominator. Remember it, if you are getting x power 4 in denominator, then in that problems we should try to divide numerator and denominator by x square. But this is not a hard and fast rule. It is practically applicable in such type of problems where you are getting x power 4 in denominator. Now if you divide numerator and denominator by x square, what happens? This becomes integral x square plus 1 divided by x square whole divided by x square minus 1 whole square by x square dx. This result you will get. Now further, if you want to write this whole integrand, how to write? You see, just divide, break this integral in two parts. Now what happens? Integral 1 plus 1 by x square dx divided by. Now take this x square within the bracket. What happens? You will have x square minus 1 by x whole square. This thing you will get. Now break this value also in two parts. What happens? You will find that this becomes integral 1 plus 1 by x square dx divided by x minus 1 by x whole square. Now boys, if you take x minus 1 by x at z, what happens? Let x minus 1 by x is equal to z. Now if you differentiate, differentiation of x is 1 and minus 1 by x is 1 by minus 1 by x square. So it becomes 1 plus 1 by x square dx is equal to dz. So what you observe here, this numerator directly appears and this equals to z. So what happens? Therefore I is equal to integral dz by z square. Dz by z square. This z square should be taken in numerator, integral z power minus 2 dz, and further the integral of z power minus 2 is minus 1 by z plus c, that is z power minus 2 plus 1 divided by minus 2 plus 1. So you can write minus 1 by z plus c, and further after simplifying, putting the value of z, you can write minus 1 by x minus 1 by x and plus c. So this will be your answer. So in this way we can try this type of problems where x power 4 exists in denominator by dividing it by x square. Boys, we will discuss more and more problems later on after discussing the next exercise, that is method of substitution part 2. And in that exercise we have to discuss few formulae, and based on those formulae we have to solve few problems. So wait for my new video, and it will be available as early as possible. So you have to solve the problems based on method of substitution exercise, first exercise, all the problems you have to solve. So thank you boys.